In New Hampshire, there is one animal that evokes the sense of majesty, strength, and curiosity: the moose.
Sometimes they want us off.
A new study is underway to learn more about this incredible creature and the habitats it depends on. Leading the project is Lily Hall, a graduate student from the University of New Hampshire.
Right now we're doing some drone work, so we're collecting thermal images of the moose to evaluate like a novel technique for monitoring the moose. It's part of a larger project looking at camera traps and drones as a method for analyzing the moose.
What we're really interested in is getting a sense of how many moose are out there. Being able to monitor the moose population and get really good information on their numbers, and then that information we'll use it to inform their management, their conservation, and also learn about their biology, how they're interacting with the landscape and potentially with other species and maybe even humans.
The current population size is estimated using the sighting rate of moose by deer hunters. And so we survey 18,000 deer hunters, and we select deer hunters that were previously successful, have taken a deer in the last 5 years or so, for the number of moose and the sex and age of those moose they see while hunting during the first 12 days of the firearms season.
Aerial surveys using helicopters or airplanes were used to help verify the hunter surveys, but those are weather-dependent, expensive, and potentially dangerous.
The overall goal is to not only understand the precision of the deer hunter survey, but to learn if these new methods, trail cameras and drones with thermal sensors, are efficient, with the overall benefit of being improved understanding of the size and distribution of the moose population in New Hampshire.
As we know, moose are brown, and a lot of vegetation and ground cover is brown. So it's hard to see them sometimes with an optical sensor. That's just basically like your normal camera phone. The thermal sensor looks at what we call long wave radiation. It's basically heat coming off an object. And it really shows up as really distinct features between heated rocks or a moose or even snowshoe hares, which I think they've seen in some of the imagery. So flying them together allows you to interpret it a little better with the optical, but the thermal can really pick out those kind of moose that kind of pop out, both by their shape and overall how kind of bright that pixel is.
We're flying at about 400 feet altitude, and we're able to fly large areas. We're covering about 35 to 40 hectares in about a 25-minute flight time, which is one set of batteries, and we're getting somewhere between like 800 and 1,000 images in that time period, and we're able to detect moose from about 120 meters away.
So the drones that we're flying now actually store GPS information in each photo. It's kind of geotagged and allows us to both know where they are on the landscape or stitch them together, so we can get actually stitch 800 images together to get a landscape view.
It's been so much fun this season because we've seen the moose almost every single time. It really makes standing out in the cold worth it.
The drones are only part of this study. Camera traps using trail or game cameras also help with the assessment. The researchers recover the images to analyze.
We have about 300 of those out throughout the state, and those collect information. Anytime a moose goes by the camera, it triggers it, and we get that information, and we use that to inform some statistical analyses that let us get an estimate of how many moose are out there.
So the trail cameras and drone surveys are conducted in a range of habitat conditions that are then going to be used in population models to help us predict and project the moose population on New Hampshire's landscapes.
The hope is that this new technology will provide better understanding of New Hampshire's elusive moose and help biologists better manage their populations and the habitats they call home.